is this. And the graphical method or visual inspection method, which is the second method, which is not a parallel method. The same method is being implemented in graphical ways, and I will demonstrate that to you. Okay. So now I'm trying to explain to you what is the graphical convolution method and how it relates to the mathematical formula in here. So I'm relating both of them, right? So I have the simulation I'll show you, but I will go. So you see now I have two functions I want to convolve. I have f1 of t and f2 of t. I'll say I'm doing it through graphical means or visual inspection. So my first step is I will rotate one of the functions about the y-axis. So I have these two functions. So these are two functions. So this is, I wanted one to be transparent so that I could show you. So these are two functions. I will take one of the functions and I will rotate it. I will take this function and I will rotate it over y-axis. So I am rotating it over y-axis. So it got a rotate. Do you agree with me? Would be minus t plus a b some amount on time, or minus t plus t1 something. I increment it, right? So my second step, my first step caused a change in the formula, that with this first function, where earlier I was a function of minus, I was a function of t, I became a function of minus t. Then I moved it along the x-axis and I became function of minus t plus t1. Is that correct? I'm done with two steps. Now in my third step, what I do, I start moving this function, which I rotated around y-axis, and I moved t1. I start moving this towards the other function. So I'm moving it on the other function. So at this stage, forgive me for my, sort of not being steady. Is there any overlapping between two functions? And what's about here now? I'm sliding, and what is happening to the overlapped amount of the two functions? This is so, and that's what is called convolution. So here I would say convolution is 0 because there's no overlapping. And here I would say convolution is increasing, and increasing. So at this stage, I have gone to a maximum. I have gone to a maximum amount. If I slide it further, that overlapped area will not increase. Is now, what's about the overlapped area? Now, if I slide further,
Decreasing.
it's
It
decreasing.
will reduce.
Okay, so decreasing. And it becomes what? What is here?
No overlap.
0.
Yeah.
So this is what the convolution. So if I want to draw the convolution, so let me, you remember my movement? At some point, I started overlapping, and overlapping increased. This is overlapping. And this is I'm moving. This is moving. So overlapping increased, reached to a maximum point because the scale was longer. So then it stayed the same. Then scale started moving out of that half circle, and then my convolution started decreasing, and then they started no parallel and became 0 again. Right? So my one function was of this shape. My other function was of this shape. So that was my f2t, and that was my f1t, and this is what my convolution is. So are you guys with me on this? Relate that in there. So my t earlier, I now change it to tau so that I'm not confusing with t. So if I was a function of tau, I rotate it, tau would become what? Minus tau?
Yes.
Okay, so this is my one. Then I would shift it by t. Shifting a t, what I would do, I would add time, right?
Yes.
Okay. Then I will multiply this flipped and shifted function with the other function. Multiplication is what I was moving that scale into that half cycle. So I would start sliding. That's what multiplication means. Then I calculate the area under this product. So area under the product, right? Overlapped area, total area. So mine was transparent, so there were two areas. So I will just sort of, multiply them, right? And then calculating the area under that product. So in the beginning, there was zero because there was no overlapping area. Then the overlapping area started increasing and increasing till it reached a final, and it stayed here because my scale was longer than the other object. If it would have been shorter, right away here, we might have started decreasing. So it would depend on my shape. And then we finished that length, and then overlapping started decreasing, and we reached to a minimum, and then there was no overlapping again. So that's what calculating the area under this product, that's what the convolution is. Okay.